31-3 notes. Continue. This is question 3. I have the formula ready to go. So we need to find the apothem and the perimeter. So it's going to be helpful to draw the apothem, because 7 is not the apothem. It's not from the center to the side. It was center to vertex. That's the apothem, center to the side, perpendicular. So it's good to label that A, apothem. Okay, so to find the perimeter, that's going to take a little bit of work because we don't know that. We know we can maybe find that part. Let's find the apothem first. So just like we did in the other examples, you need to find that angle. To find it, we take 360 divided by how many sides we have, so count them up. We have 9 sides. 360 divided by 9 is 40, divided by 2 is 20. That's how I get that angle. 360 divided by 9 sides, then divide by 2. All right, let's use SOHCAHTOA as we did in the last two. I picked cosine because I have the adjacent and the hypotenuse. Adjacent first over hypotenuse. And you should be able to cross multiply and find A. So my apothem comes out to be 6.57784, which I'm not rounding yet because it's not my final answer. It's not a big deal if you do, but I like to only round the final answer, not everything. That's the apothem, so that's going to go up in the apothem spot. Now, perimeter. I don't know the outside, but I'm going to start by finding part of the outside. I'm going to start by finding that little piece, which I'm going to label B. That little piece is part of the perimeter, so we'll find B first. So let's use trig. Ignore the A. We have the opposite and a hypotenuse, so sine of 20. Because from the 20, we have the opposite, B, and the hypotenuse, 7. Again, solve for B by cross multiplying. Pause the video at any time if you need to think about something a little longer. Now, that's B. That's not the perimeter. That's just B, which I'll highlight in purple. That's just that part, which now I can find the whole thing. That whole side is B times 2. Which is 4.788. That's one side of this regular polygon, and each side is that big. There's 9 of them, so that side times 9 gets you the perimeter, 43.09. I rounded that one because it's still in my calculator. Multiply it out to get your final answer. (141.73). There's no units, so it'd just be unit squared. You might see it written as U squared for the label. Instead of centimeters squared, it's just unit squared. Question 4. We have the formula written, and lucky for us, the apothem is given. The center to the side is the apothem. So we know that without any work, 4 root 3 is my apothem. Now let's find the perimeter. We're going to have to start by finding a little piece, then we'll double it, then we'll find all of them added up. We'll call it B. Remember, that's not the perimeter, but that's part of it. So make a triangle, find that degree. Just like before, that degree is 360 divided by how many sides? So there's 6 equal sides. 360 divided by 6 is 60. And then I want half of that. So 30. Again, pause when you need to. Set up trig to find B. What sides do I have? From 30, opposite, and adjacent. So it's got to be tan of 30. Opposite first, so B first is opposite. Over adjacent, again, we've done this several times now, cross multiply and solve for your variable. Make sure you put parentheses after you type tan 30, parentheses, times 4 root 3. Do it carefully and check it. If you get exactly 4, that's not the perimeter. That's just B, which is labeled in your picture right here. So if that's 4, then this whole thing is double, or this side here, I should say, is double 4, so 8. And each side is 8, so 8 and 8 and 8 and 8 all the way around. 8, 6 times 8 is the perimeter 48. Carefully type all that in and write your answer. One 166.28 units squared will be the area of that regular hexagon. Question 5. Pause it, go ahead, plot your vertices, and then play it. Here I have them plotted, and notice it still is a polygon. It's not a pentagon or hexagon, but it's still a closed figure of straight sides. It has 4 sides, so it's still a polygon. Now think about if it's regular. If all sides are the same and all angles are the same, what shape is it? If it has 4 sides and all angles are the same, it's a square. So I could still use this formula that we've talked about, or that might be kind of hard to find the apothem and the perimeter, so let's just do a different formula since it's a square. So a square, like a rectangle, is area equals length times width. Some say base times height, same thing. So that's a L length times width. Now remember, if it's a square, both sides are the same, so it could be written as like length times length because both the length and the width are the same. So it's like the same thing twice, which you'll usually see in a textbook it written as S squared, meaning one side times the side, that side times the next side. They're the same, so side times side, side squared. That's the formula for a square. Now let's find this side. Find the distance. We don't use distance formula, we use Pythagorean theorem. So how far apart are they in the x direction? Count it out, they're 9. How far apart in the y direction? Count it out, 2. Now that you have two of the sides, you can do Pythagorean theorem to find the side you really want, the solid green side. So, Pythagorean theorem, 9 squared plus 2 squared equals c squared. So that would be 81 plus 4 equals c squared. So that would be 85 equals c squared. Square root both sides. C is square root of 85 is 9.2195. I think that was a 9.5. So take that number and square it. I wouldn't round, I've just taken it in my calculator, square it, and you get exactly 85 units squared. Okay, so you could have used the 1/2 apothem perimeter, but because it was a square, we can just do that. Sorry about all that. In the corner, you might just see an excerpt from your book, which is just an example to show you if you wanted to use it. So there you go. You can go ahead and start your homework now.